Today we have a special guest, CL from Recce. We are gonna talk about how to trust like AI coding agents on top of our data. We're gonna have a live demo, 10 minutes from Chiro, followed by 10 minutes from CL. Bauplan is gonna be the infrastructure that is gonna run the workflows, and we're gonna have fun together. Please feel free, to drop any questions in the chat or in the Q&A. I'm gonna do my best, to interrupt these guys and have a chat. Floor is yours.
Okay, awesome. So I can share my screen. As usual, we're going to start with a very super quick introduction to the kind of problem space, and then we're going to jump into a demo and look at a demo as quickly as possible because that's much more interesting. So essentially, what we're going to talk about is how we're going to trust how you can trust AI agents when they touch your data. The general framework and the way we think about this is that we, of course, are all impressed by how powerful AI agents are becoming very quickly, and companies are trying to get agents to do as many things as possible. Getting data to the agent is particularly important because it makes the agent able to reason about specific data and specific problems that have to do with your business and your company. But when it comes to touching the data, we kind of have to slow down a little bit, which is kind of anticlimactic because often using tools like Claude Code, we get so much stuff done. You get this boost in productivity and in production. But then the data are a bit more complicated. Typically, our AI agents are very good at writing code and are becoming really software engineers in our organizations, and that's because the cycle where they read, generate, run, revise, and then they get to a PR happens in a very observable and contained loop. And it happens also on a tool chain that we all understand and we share, and we've been using for years in software engineering, which is, we all know what an IDE is. You have your code that is stored in local files. You have a terminal to run those files, and you have Git. You have this system that you use to have several different people working on the same code base. You have a way to time travel, to roll back, and to isolate the changes that you do on a code base. And when you get to data, this is a bit different because data is typically non-local by default. So it typically is in a database or a warehouse or a data lake or a S3 bucket somewhere, like in object storage. So it's not really something that happens on our computer. So changes also impact production systems. So when you change a table, there's a bunch of downstream services that trust that table. And now when you have an agent changing that table, everybody is a little bit more careful because it has an impact on other systems. And there's no Git. It's one of the main problems that you have with data is that you have ways to time travel, but there's no equivalent of something that is as straightforward as Git, and it doesn't have the same mental model. In fact, if you ask Claude to do something that I'm sure that every person who ever managed one data pipeline in his life has done, which is just backfilling, for instance, can you add a new column to some old data? We're asking the agent to change several tables that other application trusts. So this raises several questions. What about isolations? How do we do this, safely, and how to make sure that everything that the agent does is correct? How do we deploy? How do we make the changes that happen? How do we publish the changes that the agent can create safely and in a workflow that we understand and we trust? And how can we roll back? When in this situation where you change multiple tables, how you can roll back in one swoop as quick as simply as you would do with just rolling back a Git branch that has several changes on several files. So what we're going to see today is basically a way to engineer this system and to answer all these questions. The way this is going to work is we're going to put together Recce and Bauplan as together, they very much solve all the problems that I just mentioned. Bauplan is a data infrastructure. So basically is what your agent will use to manipulate data and to run compute in the cloud. And it's a special kind of infrastructure that is built specifically for AI agents. So it has this isolation in mind as a primitive. So you're always able to let the agent alone, touching the data without worrying too much about the consequences. But then, like agents will do a lot of explorations, and we're going to create like different branches, different experiments, some of which will be discarded because the cost of producing them is very low. Some of them will be merged and will go to production, and that's where Recce comes in. So Recce is a data review tool that essentially is going to help um, understand the changes not only on your code base but on the data. When the AI changes your code and the code is a pipeline, just understanding the code is not enough. You want to have a good understanding of, for instance, what is the impact on the downstream systems, what is the diffs between the different experiments that I have, what is the lineage. Like, you want to understand what are the consequences of deploying something, when deployment means writing new tables. And that's what Recce augments, that merge and deploy experience. So in this flow, yeah, I think I said most of this. So Recce will in that workflow helps us having that human like the human in the loop part of it. Like, the Bauplan will allow your agent to freely experiment and run compute against your production data without worrying too much. And then at a certain point, we will have essentially a CI/CD process, and we will have a person involved in reviewing a merge of the new data, and that's where Recce comes in. This is the
Sure.
general. Yep.
Sure, we have, I think, a question that is kind of like Git-for-Data related.
Nice.
Let me copy and paste it here so everybody can also read it. Um, so the question is basically says, you mentioned like there is no Git-for-Data when you talk about, what is like
Mhm.
standard flow with like traditional platforms. Say, can you walk us through what isolation actually means in practice when an agent is running?
Yeah, absolutely. I'm going to show you in the demo, which I think is like kind of powerful. But as a mental model, the way you should think about isolation in a system like Bauplan is you have multiple tables that basically comprise your data lake. And that data lake can be branched entirely, creating a version of all your tables. That version, like that is a branch. And that happens through a zero copy operation. So what we're actually doing here is creating sort of a sandbox space in your data without actually moving the data and copying them like from one place to another. Once you are in that space, you can write new data, and then you're going to merge that as an atomic merge. It's mostly got a copy. It's mostly merge on write, and it's very efficient in terms of managing your the production of like extra data or just like copying data around. Yeah, I'll show you in the demo. Um, as I was saying, like this is a setup, generally speaking. This is the usual setup that you have when you work with Bauplan. You have a local project, which is just your IDE and a bunch of files and possibly some skills. Skills are markdown files that instruct your agent to do more articulated workflows. We're going to see one skill in the demo. And then you have, of course, your AI agent, which is the core of your workflow here, and that really is the tool that we want to enable to do more here. And then you have your cloud infrastructure that is built specifically for Claude, for your AI agent, not specifically for Claude, for any AI agent. And the AI agent will call that just by writing code essentially in your IDE locally, and that is either a bunch of CLI commands or just like Python SDK that is run like a Python file, and that is going to call like a cloud executor, a cloud executor that will manage like the compute and data management for you. That's kind of like the general setup. If we don't have like any other question or anything, like I'm going to jump right into a demo.
I mean, we have a question about there's something like why is the MCP optional?
Oh yeah, that's a fair point. So MCP is a protocol. So for the like, I'm sure like most people know here, but like MCP is a protocol to let your tool talk to an external service, like your AI agents to talk to an external service, and wraps often like APIs. So Babylon is kind of built for agents from the ground up. So the MCP is not really necessary unless you want to use it from another type of interface like Claude Desktop. But if you're using your IDE and Claude Code is running commands in the terminal, the documentation, like basically the CLI commands and the PySDK are simple enough for the agent to just like figure that out and run those tools like bash commands or just like writing a Python script, which makes the design kind of like simpler. So the general setup for developers with Bauplan is like there's no need for the MCP. But we have like customers that, for instance, use that across different tools. Sometimes it's Cloud Code, sometimes it's Cloud Desktop, and for Cloud Desktop you can use the MCP.
Sweet.
All right, demo. So let me jump to the demo. The first thing I'm going to do, I'm going to start from describing like a little bit like the primitives through the UI. The UI that you see here, like I think is a fairly, straightforward UI that most people will be familiar with. It's just a bunch of tables right here. The tables have like their schema. You have the possibility of like previewing your data, of you have an interface to run queries. Like this looks like very much like other systems that you use to, manage and deal with tabular data. The main difference here is the fact that we have like these branches. So all this long list of branches that you see here are the concept that I was mentioning before is a data branch. So it's very similar to a Git branch, but this is effectively a branch of your data. So it's a copy, it's a version of your data lake. It's very similar to a Git branch, so it also has a Git commit history, which is is basically an immutable ledger of everything that happens on your data. If you update a table, if you delete a table, if you write a new table, if you import new data, like everything is going to be recorded immutably here. And it's going to be assigned a hash that works as a time traveling device, essentially. So if I click on any of these, I am kind of like traveling back in time to the moment where that is referred to with this hash. And when I look at the tables, I'm actually looking at the tables at this relative to this hash, right? This general workflow, think like we're going to use like this table right here. For instance, like this is a table we're going to use for our pipeline, which is just a table that contains some data, some synthetic data from Instagram engagement. These are the primitives that our AI agent will be using. So I'm going to switch to the IDE now and do this like with Claude Code. What we're going to ask Claude Code to do is to take that Instagram table that we just saw and build a pipeline on top of that. And while doing that, we're going to show how the branching works. So we're going to just like run, whoops. We're going to just run this right away. So it's going to use the skill. It's the data pipeline. So this is my prompt. Let's build a data pipeline that takes the Instagram engagement data and calculates different user segments by engagement level. We want this pipeline to have an intermediate step. So we create two tables. One is the engagement features, which we can reuse for other things as an intermediate artifact. And then finally, we have a table with the actual segments. Right now, Claude uses a skill. A skill is, as I was saying, just a simple markdown file that instructs our agents to do certain things that are a bit more complex. So in this case, it tells, like, for instance, this is how you build a pipeline. As you can see, you have this initial like best practice, for instance, that already says like, well, you never run pipelines on the main branch. You always use a separate branch. The only way you have to write into main is by merge. There are no exceptions. So what the system is going to do now is fetch the schema of that table, create a new branch, which is this one, just by running just a bash command. And now he's going to just like write Python and SQL, which is the actual pipeline. It's going to write that as a file that lives here in your IDE, right? In fact, if I go here and I look at what this looks like, it just created like this new folder, which is the Instagram engagement pipeline. And it's starting now to iterate on the code that will actually be the pipeline. And it's going to just like run the pipeline. This is the code. I can give you an example right away. Yeah, so it's basically writing just like a bunch of Python Python functions that will have a decorator that tells like this is a function that's going to be executed in the cloud as a job at scale. These are the columns that we expect and the columns that we that we read from the data lake. It's very declarative and very simple. All the infrastructure is declared in the code as well. So it's very code first. This is the reason why it works so well with agents, is that it's extremely code first in its design. But that's all there is to it. Like it basically just like writes a file, which is with the file with the code that I just showed you, and runs it in this branch several times until it gets ready to publish these tables and say just like, okay, so I think the pipeline runs, the data looks good. I'm going to write some new tables. And in fact, like now we have this new table here, this new branch here, and some new tables in my branch. So if I go back into my UI and I search for a new branch, I'm going to find this new branch. And if I search for engagement, I'm going to have like this new tables that I just created, engagement features, for instance, and user engagement segments. These are new tables that I just created, that the agent just created for us. And I can run a query against these if I want. Oh, that's already there. Just to make sure that these tables are actually true and we put actual data in it, which works. If I go on main, like what I have here is that these tables might not be here at all. In fact, if I ran this query again into main, I'm not finding this table because this table now exists only in this data branch. I can ask to merge. Once we have the merge, we're going to have like these tables in main. Now, what is the point of the deploy step that will benefit from an extra help from the agent at Recce? I'm going to just like run another prompt here. It's going to ask to basically take the pipeline that we just created and say like, look, I want to create a different version of this. I like the segments of engagements that we got, but I want to detect whether there are a lot of bots. And so I have to change this pipeline. I have to get like some new data in. I'm going to read new columns that I think are signals that I have to read to understand whether a certain user is a bot. And I want to have like a classification of my users, not only as top engagement, medium engagement, low engagement, but also if any of that looks like a bot. And to do that, I'm going to change like an existing pipeline. So if this were production, we are effectively changing a table that other consumers trust. The mechanism with which we're doing this is exactly the same that I just shown you. So the agent is going to create another branch, is going to create another pipeline, run that pipeline inside of that branch and modify that table. And at the end, we're going to have a final branch, like another feature branch that is called bot detection. And we're going to have different versions now of the same table living in different branches. And you can imagine this like being like you can spin endless like numerous agents doing this in parallel all the time. And you're going to have like so many different experiments that we want to run. Now I'm going here and I look at my table here and I can see that the schema of this table, for instance, is very different from the schema of the same table into the main branch. And so at the end of the day, now I have like several versions of it. Some of them will hit the mark, some of them won't. And I need a way to review them and make sure that when I go into my deployment phase, I have a structured way to do that where a human can do a good review of what happens before deploying. And that's where I hand it over to CL, who's going to show you how you can do that with the data review agent by Recce.
Thank you, Jiro and Matt. I'm CL, CEO and founder of Recce, and then Recce is the data review agent. And then, we have a question.
Yep.
What is the means of data validation here? Like I will be talking about like how does the Recce help like human and agent review the change. But from like I guess for Bauplan, there's built-in validation when the production pipeline is running, right? So it only merges to the main when those tests are passing. Do you want to add something to that while I share?
Yeah, just like the way you should think about that in Bauplan is that like every single change that happens always in a branch. And how many tests you want to add to that process of merging the branch depends on you. Our platform comes with some built-in tests. You can bring your own tests if you like other libraries or you want to write your own tests. The tests are usually other functions that are mapping your data onto a certain outcome that you expect. But the mental model you should have is there's no change in Bauplan happens without like an extra step of validation.
Cool, very cool. And then so I'm like just gonna talk to everyone about like what does that extra step means like when it's like fully automated or you need some human in the loop, right? So the recap for like Bauplan gave us like safe execution on branches. The change ran in isolation. Nothing really touches production until this merge. Now the question is like, should we actually merge that? How do you review what's changed in data, right? So continuing the example from Jiro's demo, we have the engagement data pipeline here. So this is like representing the change that we added the bot detection. So the first thing that you launch Recce is that you can see an impact radius, as in what Jiro was doing, like comparing the schema. You can see visually here, and then how the downstream model is now changed that, and then only like one really important column mattered, which is the engagement segment, right? So what you can normally do is you can do like a profile diff to see, okay, how is this actually changing? We are, I guess, expecting a new segment to be here. So while this runs, I will like, all right, here. You can see that this thing count is like before it was 4 segment, now it's 5, right? And then so you can see that this only highlights the semantic changes of the column that's really impacted. You can see there's added column here, and there's like something in the intermediate model where the composite score is probably like affecting the engagement segment. So you might want to check that profile as well. And then so once you are happy with the kind of like, okay, this is what I expected, you might want to dive in deeper, like taking a look at the top K for the actual data. And what Recce does is like doing this efficient query to show you what really matter for you to decide whether this will be merged or not, right? And then the problem here is really like sometimes this has business consequences. You have downstream consumption of the model. So what we can do is you can add this to a checklist, and then so this will be something that is shareable to the entire team or whoever needs to approve that. Okay, so I can show you a little bit more, but I will like dive into the agent part because this is such a tedious work. You have to go through all this, and then what if an agent can do that for you? So I'm gonna show you that before like showing other features of Recce. So here I am again running a code. You can see I sandbox it. So it's very important to sandbox your agent, and then just like what we're doing with Bauplan, sandboxing your data, right? And then so what I'm gonna prompt the agent is that I'm gonna say, okay, I've changed the engagement pipeline to add bot detection. Now, so on my dev branch, can you compare the results between man and my dev branch, which is this branch, right? And then to see what change. And then we have a skill that is with Recce to work with like DBT, but Bauplan is a new thing we support. So the skill is not optimized for that yet. But basically what I'm telling it is that, okay, recommend if we should merge this, okay? And then prepare like a detailed report in a markdown file. Okay, so it's gonna take a minute or two, and then I can continue to show you other things in Recce. So basically you can see that this provides the connection to the two database snapshots that you can do arbitrary query, and then that you've seen the profile comparison or the top K comparison, and then you can do like a bunch of this is a bunch of like value comparison as well. You can compare basically like if any of this column change in a way that makes sense. So this will be like, for example, all the columns are the same except engagement segment, which is what we expected, right? And then so the other thing you can do is you can run arbitrary query. Like if you have like a summary query or a downstream report that is a specific SQL, you can run like a comparison for both branches and then see how this query differs in this thing before you merge that to production. So the whole thing is that gather enough evidence that why this change is good and it earned this place to go into production before you break something and then people complain to you. So I think like Bauplan and Recce is an excellent combination here. All right, let's go back to the agent to see what is it trying to do to determine whether you can merge this or not. Okay, so you can see it's like doing to understand, and then it's using the lineage diff tool provided by Recce. It's trying to see what schema changed, and then what value changed, and then, oh, okay, so engagement segment is only column with value change because the other thing are untouched, right? So the reason we do this is because like unlike Bauplan, there are like other orchestration which can be like materializing table in a different way. So from time to time, you might need to still compare the value. But I think the benefit for Bauplan here is very clear, is that you are isolated, nobody's touching this part of the data, and then you can compare and then only verify the logical changes you make to the pipeline. Okay, so you can see it continues to run a bunch of other things, and then it tells you that, okay, so we now have four new column, 14 existing, 100% match, and then we have this engagement segment, which has most of matched, and then some users are now classified as bot. So these are kind of the finding, and then so it's safer to merge. There's no breaking thing, blah blah. But you might want to check if there's downstream consumer. And here's the part that matters a lot in Recce, because like if you have the entire data lineage like supported by Recce, for example, if you're mixing like DBT and Bauplan, you can essentially let Recce agent do the downstream verification for you, because it knows that exact like column that's impacting for downstream usage. So here, like this is an example. So we don't have any downstream consumption for that final node, which is the engagement segment. Okay, so this will be like the final recommendation from agent. So just imagine your PR should like accompany with this report, so that not just you who's making the change, but also whoever is going to be impacted by this, people reading the report, people like consuming the data, can all like contribute to say, hey, I think this is like correct. Okay, so this is pretty much like what Recce does, and then again, the Bauplan integration with Recce is as a pilot user only for at this moment. So reach out to me if you're interested, especially you have a hybrid environment where you have like Bauplan or other things like DBT.
Siao,
Yes.
we have a question about I mean you show like part of your UI where you see the comparison of like lineage, row, counts, distribution, column level. It's a pretty like practical question. So which one of these catches the most, bugs in practice?
Yeah, so great question. So I think this is like case by case. Usually you start with like if the lineage produced something unexpected that you didn't expect that part of the deck to change, right? This is immediate like short circuit. It's in, oh, I didn't mean to do that. And then you start validating like before the final validation, right? And then there are so for unintended changes, these like the lineage comparison or the value comparison catch that pretty good. For intended changes, because you like for example what we just showed, we do want to change engagement segment, but we want to know the scale of the change, right? So people would need to actually read kind of the impact, like top K or a histogram change,
Mhm.
to share with people who are with more domain knowledge, because you might be like taking a spec about making this change, but you need to discuss like what this business impact is, right? So this becomes a collaborative issue. It's not like purely technical, because the code is correct, right? But whether the code represents the correctness is another thing. That's what we wanted to help here.
Thank you, Sial. I think we have a question that can be for both of you guys. I said, you both use like Cloud Code. Can I use like Cursor, like Copilot, or even my own agents?
Yeah, for I'm assuming both it works for Bauplan as well. For Recce, like there's the NCP server, and then as you can see, there's the standalone UI. that works well with agent. And then if you're on Recce Cloud, this will just be integrated. But for like the use case where you are authoring the pipeline or reviewing the summary, this all work together with either the skill or NCP.
From the Bauplan perspective, your agent is like we don't provide you an agent. We don't want to. Like what we do is we provide the infrastructure for your agent to be able to work with your data. So any agent of your, I use Claude Code just because, like whatever you feel like. Yeah, like is the point is that we think that the usage of agent on your data raises a number of infrastructural questions about like how do I engineer a thing that is correct by definition? How do I engineer something that is also affordable for the agent to run a lot of things? Like there's several questions about like your infra, and I don't think like developers should care. They should care about agents. They should care about like putting as many agents as they can in production and have them to do like things that are valuable for their business. So the infrastructure should take care of that. Matt, I think like there's a couple of questions um, in the chat from about like the architecture and the validation.
Um, yeah,
Yes, there you go.
yeah,
Yeah.
you're absolutely right. So we had a question about what is the underlying data warehouse and what is the role of Iceberg basically? What are the options? I think this one is
Yeah.
for you, Chiro. And then we can
Yes. So Bauplan is effectively an execution layer because a lot of the primitives that are needed for your agents to be able to kind of like run as many experiments and as many jobs as they can and the developers in your team like be okay with that are not exactly available anywhere else. So what we typically do is we integrate with other warehouses and other compute engines or other catalogs using the handshake of Iceberg, which is an open format. So you can think of Bauplan as a lakehouse to a certain extent, like what is behind the hood has a lakehouse design is based on Iceberg. What it in practice means for our customers is that they have some data in a warehouse or in an S3 bucket, and the data never moves from there, but it gets processed by Bauplan and then rewritten back into their main single source of truth.
thanks. I think we have a pretty detailed like question for CL.
Yeah.
And so, what test setup do you use to ensure Recce interprets the data correctly? Do you utilize a particular tool? The show method regarding value changes and such are so useful. Do you plan to extend this to provide directly by high validation, by a validation view by providing a sample of change example for faster inspection?
Yes. So you can actually do like a value comparison for any column. And then so this will give you the opportunity to look at actual like row by row and then the specific change ones. And also you can apply some sampling to that to if the data is large. So for our example, there's like 1.5 million rows. So it is not too bad. Okay, so you have, okay, so this is the value diff, but you can also do a like a row by row comparison for just run the query to that. So you can just do like select star from this and then limit or do a sampling there, and then it will show you kind of like the row by row changes here. And then so what setup do you need to make sure Recce interprets the data correctly? So context is really important. So what those matrices mean, and then what your change intention, like if you're adding a new column, what's the definition for the bot? So these are all like helpful for the agent to decide how they will use the tool provided by Recce, which is like basically getting the data efficiently. But at the interpretation level, it is still done by the agent. So you need to provide that context for the agent to decide, okay, now I'm getting this bunch of data. The data looks like this in profile or histogram. Does that make sense, right? So we're helping the agent to make sense out of that to help us.
Thanks, CL. Um, I think we got a question related to atomic publish. So I think it's for Chiro. So what does a rollback look like? Is it instantaneous? How does that compare to, I mean, like teams can do today?
Okay, so the merge mechanism works pretty much like this. You create a branch, and that branch is just like is a zero copy operation. So it's basically just like metadata. We don't copy data in the branch. But when your pipeline will write new data, which ultimately is a bunch of files sitting somewhere, that is going to be written in the branch. And then so that's where the computation happens. When you want to merge, what Bauplan will do is atomically swap the metadata pointer of all these new tables onto the main branch. And so in one single command, you will have like all the diffs, all the new things all the differences, all the changes will be merged into main as a one single atomic operation. That also guarantees you that for multi-table pipelines, like for complex jobs, you never have a situation where a job fails halfway through and you don't quite know whether like some things are updated and some things are not. Rolling back works exactly in the same way. So like because this is an atomic multi-table operation, the rollback like works in the same way. So you can kind of just like roll back the tables immediately. Is
Thanks.
is the closest thing you can think of Git. Like is like your mental model should be like this is approximating as much as possible what you do with Git with code with your data.
Thanks. Yeah, we got another like Git related question that was covered by this answer. So we can move to, I think this one is obviously for CL because your name is mentioned. And so say when you said something that is like when AI changes your pipeline code review is not enough. Why not?
Yeah, I mean, code review looks at the code only, right? You can do as much like deriving the semantic if it's correct, if it's like good, conforming to your like coding style or all that. But without seeing the data, you don't really like actually like in software land, it's like running the test, right? So without actually validating the data, you're not doing that. But what's interesting about the data testing is that like a lot of the tests are basically testing the shape of the data, like nulls or ranges and all that. But semantic of data is really hard. So it's almost equivalent to like a user acceptance test in software, right? So what we need to do is basically surface these signals and then ignore the noise, because if you're comparing all the data, it's going to be massive. Especially you have a more complex stack where you have a downstream consumption. So how do you like optimize this and then show the human in the loop that what really matters to decide? So that's the harder problem because I mean you can of course like given Bauplan's infra you can query all the data in different versions and compare them, right? But the problem is really not executing those comparison, which is an outer join. But the problem is like interpreting that data is actually aligned with your intention. And so we are like helping to kind of make sure that is like as like directed and concise as possible for human. So you can see like the for example the Recce summary we just generated would give you like only the data is relevant to the change, and then how is it supposed to be correct? Yeah.
And like, if I may add on that, like one big thing is that in my mind is that double checking the data, having a good understanding of the semantics has historically been a very complicated thing to do. Now we're all excited about to the prospect of having like AI agents being able to reason around the data. So, and which I think is a true thing. It's useful. It can be done. Um, I like we have customers today that do that like with agents, and the agents are surprisingly smart at understanding like the breadth of the data, the semantics, and the relationship between the data, provided that they have enough stuff in the context.
Oh yeah.
And so like that's the main problem that you will have like with your infrastructure. So if you're thinking about these days, if it's like, how should I rethink my infrastructure to be AI first? That I would say like is one of your main concerns, along with isolation and so on, which I think like is a big thing because you want the agent, you don't want to be careful. You want the agent to go crazy, but like you want to be sleeping at night. But like the other thing is your data infrastructure entirely expressed as code? Like, can you put everything into context? Because if it's not in the context, it just doesn't exist. And one main problem of your data infrastructure is that it's fragmented across so many different places. And a lot of stuff happens in a console. So like it happens like with people clicking around.
I think we have one more question for you, CL. I don't know if you can read it here in the chat, but it's basically say when AI validates your change response review is not enough. LM judgments like overall work pretty well. Yet I did not trust a validator fully without concise just approach of the validator itself.
Mhm.
Would you like to elaborate on this one?
Oh yeah, sure, sure. I mean, thank you for the feedback and question. And then so yeah, the approach that Recce takes is really it has also the build the construct that could represent like what validation needs to be done, and then have we done that, right? So you can see like from a very high level overview, like the column level lineage tells us like semantically these are the area that changed, right? And then based on the level of change or the type, we can like the agent can infer like what checks to be done, or something it's maybe low risk, it's like ignoring the change to be verified fully, because you know that the comparison is going to yield nothing, right? So the question here is that can the agent provide us the proof of a I open decision that we decided to validate this way, and then here are the results, and then here are the gaps. But we think those gaps on testing are safe because so and so,
Mm.
right? So this is the whole thing that I think at the end of the day, what like if like the agents are doing so well, and then like creating all this code, and then of course the review becomes a bottleneck, and then we're already seeing in
Mhm.
software land. Right. And then for a data review, I think it's even more involved, because you have a lot of like stake once this goes into production, right? So like how do we like optimize this workflow, and yeah, so but love to like exchange notes, and then if you've seen something work well in practice. I know a lot of people are just using agent to just run, and then it will probably like write a small Python script and validate that. But then the question becomes like, how do you know that Python script the agent used is correct, right? So I think having some like basic construct that you can trust is also very important.
Thank you so much, CL. I think we are also like over time and it's time to wrap it up. So thank you so much for joining us, CL. You are a wonderful, like special guest, even if you decided to not stay across, the hallway here in the office, but you're still you are at your place in Berkeley. So thank you everybody for joining us. Happy
Thank you.
Sampadi Day. We're gonna have the next webinar with our friends at DLT Hub in a month from now. So stay tuned. You're gonna all receive like an invitation, and we're gonna continue, showing you about plan and show you interactions and integrations with all the best like companies out there. Thank you again.